One huge difference between today's automobiles and the cars we used to know in the past is that today's automobiles are more efficient in performance and also in fuel economy. This is quite different from what we used to have in older automobiles. Older automobiles had the problem being that they were fully mechanical. But in modern automobiles that you have today, you have a lot of electronic devices that are on it, and they keep the vehicle running at a more efficient rate. Now, one of those electronic devices that you have on modern automobiles that keep it running smoothly and efficiently all the time is sensors. Sensors are capable of sensing what happens around mechanical components that are in operation and then send that signal as an electronic signal to a control unit. The control unit now determines what is the best action to correct whatsoever condition exists in that environment, and this keeps the vehicle running efficiently. This is what we call a feedback loop, where the control unit is able to get a feedback from the area where the operation is going on, and then the feedback helps it to correct whatever operation is happening in that area. Now, an example of a control unit is what I have in my hand here. This is a control unit. It's actually an electronic device that is capable of communicating with sensors, and it has a microprocessor in it, it has memories, it has drivers and other chips, resistors and transistors in it. They all come together to help it calculate the different conditions that the vehicle is running at, with also the help of sensors. And here we have a few sensors. This is an airflow sensor, we have an oxygen sensor. Now, technically, it is good we go deeply to see how sensors operate. Like I said, technically, we break sensors down into three different categories. There is the resistive categories, there is the voltage generating category, and also there is the switch category. These are all different categories of sensors. We're going to be looking at them one after the other, starting with the resistive category. Under the resistive category, you have different kinds of sensors, but they operate on one principle, and that is resistivity. They all possess resistivity, and this is how they operate. Under that category, you're going to find sensors like the piezoresistive. You're going to find sensors like the thermistors. You're going to find sensors like the potentiometers. The potentiometers are capable of calculating range, while the thermistors are capable of calculating change in temperature. And then you also have the piezoresistive that can calculate change in pressure. Now, these all sensors, they all work differently, but with the same principle, though they may have different applications. For instance, the mass airflow sensor we picked the other time. This is a complete integration of mass airflow and intake air temperature sensors. The both of them together, they operate as one device, but then they are actually two sensors in one, and they are working on the principle of a thermistor calculating temperature. You also have the oxygen sensor that would also work with the principle of a thermistor. Now, under that category of resistive sensors, you have the thermistors, you have the piezoresistive sensors, and you also have the potentiometer. Like we said before, the potentiometer calculates range, while the piezoresistive calculates change in pressure. The thermistors, they calculate change in temperature. The next category would be the voltage generative sensors. Under voltage generative sensors, these sensors are capable of generating their own voltage. They don't rely on the control unit to give them a reference voltage which is worked on to give a signal. Unlike the resistive and the switch sensors, which are known as reference voltage sensors. For the voltage generating sensor, they are capable of generating their own voltage. And sensors that fall under this category are known as the magnetic inductive type of sensor, which is also a principle that is used to make crankshaft, camshaft position sensors. These sensors, they monitor the speed of rotation of the crankshaft or the camshaft, and sometimes they are also applied to wheel speed sensors where they monitor the speed at which the wheel moves on the road. And this is also known as what we call the ABS sensors as well. So the voltage generating sensors, they are capable of generating their own voltage based on electromagnetic principle. Electromagnetic principle that states that when you have a conductor and a magnet moving together, you can have a case where EMF would flow, or what we call voltage will be generated. So voltage generating sensors are capable of generating such voltage. And lastly, we also have the switch sensors. The switch sensors, they are capable of switching signals, high and low or on and off. Now, under the switch sensors, we have sensors like the Hall effect, we have sensors like the phototransistor and LED type. We also have our regular switch, we also have the Hall effect type. All these fall under the category of the switch sensor. A little bit on the voltage generating sensor, just as you have the magnetic inductive, you also have sensors like the piezoelectric sensor, you also have the zirconium dioxide sensor under the voltage generating. The piezoelectric, the zirconium dioxide sensor, the piezoelectric is made of a material that once you strike it, it is capable of generating voltage. Now the voltage generated can be used as a signal by the engine control unit. And also for the zirconium dioxide type, it is made of zirconium dioxide, which is an element that once it is heated in the presence of oxygen, is capable of producing voltage, which is also sent to the engine control unit. Now, back to the switch sensor. For the switch sensor, we said we have the Hall effect type, we have the phototransistor and LED, and we also have, lastly, the regular switch. For the regular switch, these are the switches we find everywhere. For instance, the door switch, you have the door switch, you have the bonnet switch, you have the central lock switch. These are regular switches. The oil pressure switch is also a regular switch. Then as for the Hall effect, the Hall effect type of sensor is more of what we'll call a semiconductor related sensor or a semiconductor built sensor, because it's built of a semiconductor wafer layer that is used to transfer electric current. Now, when the electric current passes through and there is a magnet in that environment, that helps to deflect the electrons, which eventually shows a switch sign, an on and off effect. Most times, Hall effect sensors are used to replace electromagnetic inductive sensors because the disadvantage of electromagnetic inductive sensor is that temperature can overheat the magnet, and you also have an analog signal coming from such setup. But in the case of the Hall effect sensor, you don't have analog signal. What you have is fully digital. There's an on and off effect. And also on the switch sensor, we have the phototransistor and LED principle, which is used for making sensors like vehicle speed sensors in the past. But modern cars don't carry such vehicle speed sensors anymore, where you have a rotary gear in the gearbox that is capable of rotating a fan blade, that is capable of putting on and putting off the shine from an LED lamp. And these all happen in front of a phototransistor, which transcribes all of that signal into on and off effect. And that is used to drive the speedometer on older vehicles. And you also have some of them that use the wafer layer, the Hall effect type. All these are all different kinds of switch sensors. They are quite different from the voltage generating. They are quite different from the resistive sensors. Now back again, we said sensors are capable of monitoring environment, taking signals, and when they take these signals, they send it to the engine control unit or an electronic control unit. The control unit is capable of working on that signal and capable of giving out an output. The output is usually sent to actuators, which we would be looking at in another class.